Okay, so let's have a look at some examples here of pH problems. Okay, so the pH of your drinking water was tested at 7.2. How many times more alkaline is this than pure water? Okay, so we're going to do 10 to the power of 7.2 divided by, and actually if we go back and we look at the scale here, so a pH of 7 would be considered pure water. So we're doing 10 to the power of 7.2 divided by 10 to the power of 7.0. And again, we can use our division law of exponents here. We get 10 to the power of 7.2 minus 7.0, 10 to the power of 0.2, which is 1.59. And what that represents is that the drinking water that had a pH of 7.2 is 1.59 times more alkaline than pure drinking water. Okay, and then what is the pH of a substance that is 200 times more acidic than orange juice? Okay, so let's have a look at, here's our orange juice. Has a pH of 4. Okay, so we're going to do 10 to the power of 4 divided by 10 to the power of something. We'll replace that something with x. This is going to be 200 times more acidic, so we're going to make this equal to 200. Okay, and again, we'll use division law on the left-hand side. We get 10 to the power of 4 minus x is equal to 200. We can log both sides, and we'll move that exponent out in front as a coefficient. We've got 4 minus x times the log of 10 is equal to 200. Remember that the log of 10 is 1. So let's do this. We've got 4. Oops, that 200 on the right should actually be the log of 200 because we took the log of both sides. So we'll get 4 minus the log of 200 is equal to x, and we get that x is equal to 1.7. Okay, so a substance with a pH of 1.7 is going to be 200 times more acidic than orange juice. Okay, and the last type of problem that you are going to see in this unit, the last type of word problem, are decibels. So this is to do with sound. How loud is the sound that you are being exposed to? I can remember as a kid going to Canucks games and they try to pump you up, pump the crowd up, make it as loud as possible, and they show the decibel scale on the big jumbotron in the stadium, and you're trying to get as loud as possible. So there's a bit of a tie-in there. Okay, so the loudness of sound is measured in decibels. Every increase of 10 decibels is a tenfold increase in loudness. Okay, so how many times louder is traffic than a conversation? Okay, so let's so we're going to do P sub T. So this is the loudness of traffic in relation to the loudness of conversation. So we're going to do P sub C. Okay, now this is a little bit different. So with earthquakes, every increase of 1 point on the Richter scale, we had a tenfold increase in the magnitude or the power or the intensity of the earthquake. With pH, every single point increase in the pH scale, we had a tenfold increase in either acidity or alkalinity. Now in this case, with every increase of 10 decibels, we have a tenfold increase in loudness. So what we're looking at here is we've got to divide that decibel reading by 10. Okay, so how many times louder is traffic than a conversation? So traffic is 85 decibels, a conversation is 60 decibels. Here's what this looks like. 10 to the power of 85 divided by 10. Okay, divided by conversation, this is going to be 10 to the power of 60 divided by 10. Okay, now we can certainly simplify those fractions. 85 over 10, we could call that 8.5. 60 divided by 10, we can call that 6. And so my next step is I'm going to use division law here and just rewrite this as 10 to the power of 8.5 minus 6, which is 10 to the power of 2.5, which is 316.2, which represents that traffic is 316.2 times louder than a conversation. Okay, how many times louder is a chainsaw than traffic? Okay, so same idea. Chainsaw registers 100 decibels, so this is going to be 10 to the power of 100 divided by 10. And we are relating this to traffic. This is going to be 10 to the power of 85 over 10, which is going to be 10 to the power of 10 minus 8.5, which is 10 to the power of 1.5, which is 31.6, or the chainsaw is 31.6 times louder than traffic. Okay, and what is the measure in decibels of a sound that is twice as loud as a chainsaw? So we want 10 to the power of something over 10 divided by 10 to the power of 100 over 10, that's the chainsaw. And this needs to be equal to 2. Okay, this fictitious sound, we want it to be twice as loud as a chainsaw. Okay, so our next step here, we've got 10 to the power of x minus 100 all over 10 is equal to 2. We can log both sides here. We're going to get x minus 100 over 2 times the log of 10 is equal to the log of 2. We know that the log of 10 is 1. So from here I'm going to multiply both sides by 2. We get x minus 100 is equal to 2 log 2. And so x is equal to 2 log 2 plus 100 and finally x is equal to 103 decibels. Well, just looking back at this, not sure where this 2 came from. I think this up here is meant to be a 10. We're using power law, so we're taking our exponent here. We're moving it out in front of the logarithm as a coefficient. So we should have multiplied both sides by 10. So we've got x minus 100 is equal to 10 times the log of 2. X is equal to 10 log 2 plus 100, and that takes us to